world, in all the chapters that we're going to do this semester, stoichiometry is the best. Stoichiometry is a way to allow us to figure out how much of something we're going to need to make something else, or if we combine two or more things, how much are we going to get out of it, right? So let's bring it home, right? Let's say you work 40 hours a week and you get paid $10 an hour, right? This is our gross pay, okay? Our gross pay. How much are we supposed to take home? $400 after a week, right? So let's say you get your check, gross pay, and it says that you got $259. What are you going to do? You're going to go black, you're going to raise hell, because something wrong. You worked your 40 hours, you expect to get your $400, right? That's how much you put in, so you're supposed to get out a specific amount, right? So, this is ultimately what stoichiometry is going to tell us. Now, if you get paid $500 after this week, you can now backtrack and see how much hours you put in order to get that much. This is also what stoichiometry allows us to do. Alright? So we're doing stoichiometry, and it's calculation with chemical formulas and chemical equations. Alright? So now we know how to write our chemical formula. We learned that last chapter. Now our chemical equations. There's some things that we need to know about our chemical equations. Okay? First thing we need to know in terms of stoichiometry is the law of conservation of mass. The law of conservation of mass simply means what you put in is what you get out. Alright? So the total mass of your reactants should be the total mass of your products. Alright? So here you have your reactants in the chemical equation. Your chemical equation simply is a way for us to represent your chemical reaction. It tells you what you have placed into the pot and what you are expected to get out of that mixture. Alright? So on your left-hand side of your arrow, that is your reactant side. On the right-hand side, that is your product side. Right? So here, on the reactant side, we have hydrogen gas reacting with oxygen gas to produce water. Right? So now, again, law of conservation of mass. What you put in is what you get out. How many atoms of hydrogen do you have?
2 or 4.
No.
Oh.
4. You have 4 atoms of hydrogen. I didn't ask you how many molecules of hydrogen gas you have.
Oh, hydrogen is the white one, no?
Hydrogen is the white one. You understand?
H2 is
Right.
1 atom. H2 is 1. H2 is a hydrogen gas.
There you go. And how many atoms of hydrogen is in that molecule?
2.
Very good. So here, how many atoms of hydrogen do you have? 4. Good. You have 4 atoms of hydrogen. How many oxygen atoms do you have? 2. So therefore, you should get out 2 what? 6 what?
I was saying 6 altogether.
6 atoms altogether. 2 oxygen atoms, 4 hydrogen atoms, but they're not going to be the same. They're going to be rearranged and bonded differently. Okay? So here you have your water molecules. Water molecules, you have 2 hydrogen each, 4 altogether, 1 oxygen each, 2 altogether. So again, you come out with the same thing that you put in. We get that? All right. Now, law of conservation of mass. Again, some more things about your chemical equation that you need to know. Again, left side, reactant side. Right side, product side. You also have your states. Okay? Your states is going to let you know what type of reaction is it going to be. Is it going to be in the aqueous state? Is it going to be in the solid state? Is it going to be in the gas state? Alright? Now, you have to know how these things behave, how gases behave, how, well, we'll get to aqueous equation in the next chapter. We also have something called coefficients. Your coefficients are going to be on the left side of your molecule. Your coefficient indicates for right now, how many of these molecules do you have? Alright? So how many molecules of methane do you have?
1.
Oxygen gas,
2.
carbon dioxide,
1.
water.
2.
Very good. Alright? So now, law of conservation of mass. What you put in should be what you get out. You put in 1 carbon, 4 hydrogens, 4 oxygens. You should get out the same thing, although rearranged. Here you have 4 oxygens, 4 hydrogens, 1 carbon. What you put in, what you get out. You get that? Alright. Let's take some questions. Okay? A solid mass of 35 grams is mixed with a solution to cause a complete chemical reaction. When we say complete chemical reaction, what do we mean?
Breakdown.
Breakdown? What do you mean breakdown? Reactants and products?
No, like you get products from reactants.
Right, but what does a complete chemical reaction mean?
All the samples were used.
What do you mean?
Science.
No,
Balance.
no balance.
All the samples it was used.
What sample? What's it called? All the reactants were used up, and now all you have is products. Now, if I tell you you had an incomplete chemical reaction, what does that mean?
You have reactants left.
You have what?
Reactants are, you have
You have some reactants left over. Very good. All right? Okay. If the total mass of product is 95 grams, what is the mass of the solution?
60 grams.
60 grams, where do you get that from?
I subtracted 95 with 35, which is the solid mass of solid.
Very good. So Vishaka figured out that you have, if your product is 95 grams, therefore your reactants need to be 95 grams as well. Given that you have 35 grams of your solid mass, the remainder needs to be a solution, which would be 60 grams. Did we get that?
Yep.
All right. Next one. Solution A, mass 60 grams, is mixed with solution B, mass of 40 grams. To produce a chemical reaction in which a gas is produced. What do we know about gases? What's going to happen?
evaporate.
Chemical
They
reaction.
evaporate.
I don't know.
It starts with E.
Extend.
Escape.
Say it loud and proud.
Escape.
It's going to escape. Alright? Great. If the mass of the final mixture is 85 grams, what is the mass of the gas that is produced?
15.
-2. reactant side is how many?
100 grams.
100 grams. You get out of your product side 85 grams. So therefore, if you subtract that, that should be the mass of the gas that escaped.
Oh, okay, so you add the total, that thingamajig total right there, and
Uh-huh.
you subtract that.
Uh-huh.
Okay.
Okay? Okay? That's what I got too, but we're gonna ignore, like this 10 right here, that's 60 right there, that's 100 right there, okay? See that, right? You see that? Okay, make that work, okay? There you go. All right. So balancing chemical equation. This right here is the fundamental of this entire chapter. If you cannot balance the chemical equation, this entire chapter will be lost to you. So we must master balancing chemical equations. All right? Yes.
You know what you taught us in the previous slide with the crisscross and stuff like that?
Yes.
Could that be used as
No. The balance equation?
like a shortcut before you balance?
No. No. There's no shortcut to balancing. Okay? Alright. Some things we need to know before we balance our equations. We have two types of numbers in our chemical equation. We have subscripts and we have coefficients. Your coefficients are at the outer left-hand side of your molecule. Your subscripts are on the lower right-hand side of your atoms. Okay? My subscripts are not to be touched. My coefficients, you can mix and match them. Okay? Change them, flip them, do what you want to them. Alright? Now here, this is your coefficient. Your coefficient tells you that you have 2 molecules of water. That looks like that. Here, this 2 is your subscripts. The subscripts tell you you have 2 atoms of oxygen. That's that and that. Did we get that? All right. Now, step 1 in balancing my chemical equations. First thing you must do is identify your reactants and your products. Okay? First equation. Now, here is where we are going to join up chapter 2 and chapter 3. What is the name of this compound? Woo! Woo! Woo!
Peroxide.
Woo!
What did I say? SN?
Uh-huh. That starts with a T.
Oxide. Wait, tin.
Tin.
Oh, 2.
The 10, the thing in the lab, the 10 thingamajig.
Tin.
The high,
What number is what?
2.
that's, oh no, that's
Oh, tin. 2.
Oh.
I'm not understanding it.
It's just
It's ionic.
No, I'm telling you nothing. Now, how do we recognize the charge on a transition metal? You look at the charge in the non-metal. What is the charge? What is the non-metal that I have?
Oxygen.
Oxygen. What is my charge on oxygen? How many oxygens do I have?
2.
Therefore, how many minus charges do I have?
4.
So therefore, what is my charge on my tin?
4.
Aha. Plus 4. So therefore, please tell me what my name is.
Oh, what's 4 again? Tetra something.
You see how you're joining up thing? Tetra is for what?
Covalent.
Covalent compounds. Is this a covalent compound? What kind of compound is this? It's ionic. How do we name my ionic compounds?
Tin.
Tin,
Oxide.
4, oxide. Uh-huh. Did you get that? No.
I don't know what it is. Why
Right?
can't you say with the 20?
20. What 20?
With the box right there, the 20, that's it.
No, you can't do that. You have to know more. Alright, so what's this?
Hydrogen gas.
Hydrogen gas.
Tin. Water.
Okay. So now, we are going to learn something else. We ain't get there yet. We ain't get there yet. Okay? So, we are going to learn how to read my chemical equation in a sentence. Okay? Don't be slow blinking at me, Sabrina. Okay? So, here's what these things call for. First thing you have to tell me is what my coefficient is. So for right now, the coefficient will be named molecules. So you have X molecules of tin peroxide. This plus sign on the reactant side reads as reacts with. Your arrow reads as to produce. The plus sign on your product side reads as and. We get that? Who wants to read me this in a sentence? Go ahead.
Tin peroxide and
Reacts with.
oh, I apologize. I thought that was the arrow.
You've been apologizing a whole lot today. Come on,
Tin
keep going.
peroxide reacts with X molecules of hydrogen gas to form tin and water.
Very good. Okay? So we shall be doing more of that in our examples. Okay? All right.
The first one is X10. The blank is what? Just 10?
That's our, we haven't filled in that blank yet, so you can ignore that for now. Once you fill in the blank, then we will call them out. Okay? Step 1. Identify my reactant, my product, my reactant side. Left side, product side, right side. Okay? Step 2. We're going to list out all of the atoms on the reactant side and the product side. Where's my? First thing we do. Tin. Okay? So you have reactant side, product side. I have my reactant side. I have the product side. So we're going to list out each atom that is present on the reactant side. What's my atom that's present here?
10. Oxygen. H.
Hydrogen. On the product side.
10 and water.
Right? That's what I got to. Step 3. Calculate the amount of each atom that's present. How many tins do we have? How many oxygens do we have?
2.
Hydrogens.
2.
On product side.
1.
So I got 2. Step 4. We're going to find out who's happy and who's not so happy. Okay? How do we know if we're happy? If we look alike, we are happy. If we don't look alike,
We
we're not
ain't.
so happy. Okay? So, what we're going to do then is now we're going to try to adjust our coefficients to make us happy. Now, we always want to get an upgrade. We always want to step up. We don't want to go back. All right? So here, we want our product side oxygen to match our reactant side oxygen. Alright? So now there's an order in how you make things happy. The first one that you make happy is your methyl. The next one that you make happy is your hydrogens. Then the next one after that is everybody else in the alphabetical order. Alright? So now, who's happy? Who's not happy?
Only one not happy.
Who's not happy? Oxygen is not happy, everybody else is happy. How now do we make oxygen happy?
Two.
You're going to put 2 where? Before water, product side. So you make it 2 here, you now have to readjust everybody. Okay? Now your coefficient is going to multiply by your subscript. So now how many hydrogens do you have now?
4.
Cross that out, you put 4. How many oxygens do you have?
2.
Cross that out, you put 2. So now, we need to reevaluate everybody again. Your oxygens are now happy, but your hydrogens is got inside. So you're going to put 2 where? On the reactant side where? Before was H2. Thank you. Put a 2 in front of hydrogen gas. Now how many hydrogens do you have?
4.
Cross that out, you put 4. Now is everybody happy?
Yes.
Everybody's happy. So technically, you're finished. But you're not finished. Okay? You need now to look at your equation. Whoever you have not added a coefficient to, you must add a 1. For my exam, you must add a 1. If you leave it blank, I'm going to minus points off of your grade, even if it's correct. Okay? You must add the 1. Once I know that you know, that I know that you know that there's a 1 there, then you can leave it off. That's exam 2. Okay? Alright. Did we get that?
So exam 1 has to be there.
It has to be there for exam 1.
It's the next Tuesday, right? The first exam is next Tuesday?
Yes, sir.
Next Tuesday.
Yes. Alright?
What chapters is that gonna cover?
1, 2, 3. Alright? So, here's what we have. Once we get past the writing the 1 stage, we will be writing it as this. Okay? So now, can I get this equation right in a sentence with my coefficients? Mohammed, you go with me?
1 mole cyanide per
No, that we ain't get to moles yet. You can't be jumping ahead. We at molecules.
molecules, right? Okay. 1 molecule cyanide 4 oxide react with 2 molecule of hydrogen gas. Reaction
To produce
produce 1 mole
1 molecule.
cytine and 2 molecule water.
Very good. Right? Don't worry. We gonna get more practice.
No, but what was the name of that one again?
He used the classical system of naming. We're using the stock system of naming.
Okay.
It's classical. It's stanic or stanos. We're going to just use tin.
Oh, okay. Because I'm
Okay.
like, wait, that sounds different.
Okay? Okay? So now, here we go. Okay? We're going to balance my equation. But before that, can I get it read in a sentence? Please and thank you. Who's going to do it? Who's going to do it? Go ahead, Karen.
X molecules of potassium hydroxide reacts with X molecules of phosphorus
Hi.
Phosphoric.
There you go, phosphoric.
Phosphoric acid.
Uh-huh.
To produce X molecules of potassium phosphate
Potassium phosphate, good.
and X molecules of water.
Very good. Now, do we need to go through this to balance out the equation? Do we need to do it? Yes, no? Yes, no?
Yes.
Yes? Y'all still didn't see my eraser?
No, phosphoric.
Where did you bring it?
I didn't bring it nowhere. I left it in here.
Put it in your bag.
I bet you seen that.
It's not. How am I gonna put the thing in my bag? I just go in my bag.
Wanna put some points on it?
Oh! I'll put some points. You want to put some points on
I
that?
didn't agree to that.
See? All right then. All right then. Good. Ask me what?
That was about 34.
Oh, right, like, okay. Just know I can hear earthing. Okay? My eyes might be too good, but my hearing, on point. Okay? All right. Reactant side, product side. What do we have here? Potassium,
Oxygen.
oxygen, hydrogen,
Phosphorus.
phosphorus.
That'll be all.
That's it? Over here.
Potassium, phosphorus, oxygen, hydrogen.
Yes.
Let's don't break up the marriage.
This is the only time you can break up a marriage. When you're trying to balance it, that's the only time you can break up a marriage. Everybody else, we keep them together. Okay? Now, how many potassiums do we have? Oxygen. Now,
5.
when we're counting on the entire side, not just one.
5.
5. Hydrogen.
4.
Phosphorus.
1.
Over here.
Potassium. 3.
Oxygen.
Oxygen. 5.
Hydrogen.
2.
Phosphorus.
1.
Who's happy? Who's not happy?
Oxygen and phosphorus are happy.
Oxygen and phosphorus are happy. Potassium.
Hydrogen are not.
Not so happy. Right? Who are we going to make happy first? Potassium. How do we make potassium happy? Who we want to be like?
We want to be like a product.
We want to be like the product side. So we got to make the reactant side look like the product side. All right? So how do we do that?
Multiply by 3.
Add 2 on the coefficient.
2.
3.
You're going to put 3 as a coefficient where?
On potassium hydroxide.
In front of potassium hydroxide. So now we got to reevaluate everybody. Okay? How many potassiums do we have now?
3.
How many oxygens do we have now?
8,
Uh,
4, 5, 6.
So, we're gonna have
uh.
7. 7.
8, 5.
Remember, your coefficient multiplies by your subscript.
Oh,
How many do we have here?
3.
How many do we have here?
4.
Add that together.
7.
Thank you. How many hydrogens do we have?
Now we have 7. Oh, no. 6.
Wait, I'm not counting all of them. I mean, 6.
Phosphorus stays the same. Okay? Now who are we going to mess with? Hydrogens. How are we going to upgrade my hydrogen? Multiply what by 3? Put 3 here. So now we got to reevaluate everybody. Right? So how much hydrogens do we have now? 6. How many oxygens do we have now?
3, 7.
Now everybody's happy?
With the
Are we
one.
finished?
No one?
We got to put the ones.
Okay.
I get this right in a sentence with my coefficients, please?
I hope you don't be asking that.
You think I won't?
Please don't.
Child. All right, that's yours right there. Go ahead.
No.
yes.
No.
Yeah.
I'm blank.
No, you can't be blank.
No, I'm blank when it comes to reading it.
No, well, we gonna get that together then. If you blank, I gotta fill you up.
Do you say the 3?
You gotta say the 3 molecules. 3 molecules of bananas and pajamas are coming downstairs.
phosphite, potassium,
Sounds like
you think you throwing me off. Is we said potassium hydroxide.
very good.
Reacts
Reacts with
what is that?
1.
Molecule of what's that? Hydrogen?
This is a oxy acid.
Phosphoric acid.
Very good. To produce
To produce 1 molecule of potassium phosphate and 3 molecules of water.
there you go.
Yeah, that's gonna take me.
Okay. That's how you can do the next one too.
Oh no!
All right, there you go. Go ahead, give me the black one.
Wait, but we gotta do the thing in this.
No, you can do it first. You can do it first, and then someone else can do it with the coefficient.
X molecule of what's potassium?
Don't make me start singing that song again. Potassium.
Nitrate.
Very good.
Reacts with carbon oxide, carbon I don't know. You think
What is this one? Carbonic acid to produce
X molecule of potassium carbonate carbon dioxide. What does this mean?
Don't you put things? What you do when you put things in your mouth?
E
You ate so
carbonate.
right and nitric acid. There you go. Now balance out my equation.
Oh my god. Okay. Okay, so it's one potassium.
Oh, we need to do this again?
One
Yes.
nitrate. Okay.
Reaction side, product side. What do we have?
Nitrogen, oxygen, hydrogen, carbon.
That's it? Here. Same thing. How many?
One, 6, 2, 1. 2, 1, 6.
Potassium is in 3.
Oh. Only oxygen and breathe.
2 is not here.
Oh.
2, 1, 1.
Carbon.
Oh.
When when balance, you said make satisfy the metals first, and then
Metals first,
then
then
the hydrogen,
then everybody else alphabetical order.
Okay.
would be like uh-huh.
So next one.
Oh.
So then we do potassium first.
See, then
So that.
And if N was there,
2, 1, 1.
oh, okay.
So we do potassium first.
Two in front of
in front of what?
K or
Don't tell me no K.
hydroxide.
What is that?
Potassium.
The reactant.
Oh. 9.
It's 30 already.
There you go. Potassium nitrate. So you put a 2 here. Now you gotta reevaluate everybody. How many potassiums do you have?
2.
How many nitrogens do you have? How many oxygens do you have?
8.
9.
9.
9.
Don't you got times it?
Yeah.
9.
12? 2 times, wait, you do,
times 2 is 6, and then 6
yeah,
plus
9,
3 is 9.
wait, 2 times what?
2
2 times 3.
6 plus 3.
Oh, then you add the 6, okay.
You don't add 6, we can
Add the 3, that's what I meant.
Okay? Hydrogen stays the same, carbon stays the same. Who else are we gonna make happy? Hydrogen. How do you make hydrogen happy here?
Multiply the 2 on the product side.
In front of what?
Nitric acid.
Nitric acid.
Nitric acid. Put 2 here. Hydrogen now becomes,
2.
nitrogen becomes,
2.
oxygen becomes.
9.
Are we done?
Yes. We are happy now.
No, we're not.
And they won't.
1.
That's what I got to.
Oh,
Ooh, what time is it?
we gotta
Ooh!
Oh, yes, it's a moment, c'est clean.
Wait! Read it to me in my
They
sentence!
don't got time.
I'm taking 2 minutes. Read it to me in my sentence! Who's gonna give me the sentence?
Alright.
Go ahead, Rana.
Potassium nitrate. Nitrate.
Nitrate. Reacts with.
1 molecule carbonic acid
Very good. To produce.
to produce potassium nitrate.
How much?
1 molecule potassium nitrate.
No, that's carbonate. Potassium carbonate.
Potassium carbonate
And
molecule nitric acid.
very good. Now you can go. If you were late, let me know.
I don't remember.
Huh? No. You got a whole hour. Get your life right.
Yeah, I think I just don't know how to put it in.
Professor, how many points will you take off if you have on the rest? 1. I'm gonna go get it. I need that 1 point. Yeah. Oh, see? Thank you.
It's my job.
Thank you. Say it again for this one. All of it. All of it here.
Extra points?
Yeah, extra point, he owes me. He lost the bet, so he owes me. It is, I got you. I got you. Thank you. Yes.
Oh, that is London.
I have no idea, it's a book upstairs, I know it's but I don't know exactly the reference. So you have to figure out what the reference is. Okay.
My whole family knows.
What do you mean different? Okay, yeah, that's fine. Sure. Okay. Yeah. You can go ask them in 2:15. Yeah, you can go ask them. Yes, Doctor. That's not what you use. numbers and find, and ask them the reference.
Okay, got it. And,
And
I never got no food, so I'm gonna purchase the
is it fine for the relay and I don't know another building, I know that her name is Elizabeth, but I don't know.
Okay. But you have to know these things. You have to get all the information.
Okay.
Sweetheart? Hi.
Hi.
My class finishes at 12:45.
Oh,
Okay?
sorry.
So just, you can stay for today, but just be mindful.
Got it.
Oh, she came in because of me.
Oh, okay.
Yeah.
So what's your class? What's your class?
Chemistry?
Chemistry. Oh, it's English.
Oh, okay. Totally different.
Totally different.